Hey Ramblers, this video is going to teach you a fourth way of proving triangles congruent, called the HL postulate. Now, we should take a minute to explore the name a bit. HL refers to hypotenuse leg, which of course implies right triangles. So the HL postulate only applies to right triangles. The second part of the name, postulate, is also a little bit troublesome. Many books present it as a postulate, but we can prove it, so that really makes it more of a theorem. So I will refer to this as the HL theorem quite frequently, but it doesn't matter truly whether you call it the HL postulate, the HL theorem, or just HL, as I probably will do most often. A couple of pitfalls to avoid. The first one is thinking that right triangles can only be proven congruent using HL, and that's just not true. We can still use side angle side, and angle side angle, and side side side, just as we always have. But now we can also use HL if that's what the circumstances dictate. The other pitfall is forgetting about HL, and try not to do that. So make a card and include it in the other cards that you study. We won't run across HL as often as we do the other three theorems, but it's still one that's going to come in very useful throughout the year. So good luck with the exercises. I hope you find this video helpful. Make sure you make a card, and hope you enjoy the video. Alright, thanks. There is one more thing though I wanted to include. While I was chaperoning in the gym, I took some video with my iPhone of some people on the bungee run. So I hope you'll enjoy those, and I hope your classmates aren't too mad that I included them in the video. Alright, thanks. Okay, suppose we were given two triangles that were right next to each other. Triangle ABC and ADC. And our givens were that AB is congruent to AD, and that AB was perpendicular to BC, and that AD is perpendicular to DC. Could we prove that the triangles were congruent? Well, let's go through it. The first thing to take care of is our first given, that AB is congruent to AD. There's more than one conclusion you can draw. Well, I'm sorry, there's just one conclusion you can draw, but if you know that AB is congruent to AD, can you think for a minute, what conclusion can you draw from that? Press the pause button if you have to think about it, but hopefully you can come up with one. Okay, knowing that AB is congruent to AD means that angle 1 is also congruent to angle 2, because if sides are congruent, then the angles opposite them are congruent. And opposite AB is angle 2 in this triangle on top, and opposite AD is angle 1, also just referring to this triangle on the top. Alright, let's take care of the next given, that AB is perpendicular to BC and AD is perpendicular to DC. Well, this you've gotten before. We know that ABC and ADC are right angles because if two segments are congruent, then they form right angles. Alright then, what could come next? Well, think about complements. What kind of conclusions can you draw about angle 1 and angle 3, and angle 2 and angle 4, now that you've proven that you have right angles there? Pause if you need to. Okay, step 5 and step 6, hopefully you recognize that angle 1 and 3 are complementary, and angle 2 are complementary, because if two angles form a right angle, then they are complementary. Alright, so if 1 is comp to 3, and 2 is comp to 4, and we know from step 2 that 1 and 2 are congruent, what conclusion can you draw? Pause the video if you need to. Alright, I hope you recognize that angle 3 must be congruent to angle 4, because if angles are complementary to congruent angles, then they are congruent. So now that we have 3 and 4 congruent, what conclusion can we draw from that? Pause the video and figure out what the next step might be. Okay. If angle 3 is congruent to angle 4, then side BC must be congruent to side DC, because if angles are congruent, then sides are congruent. I hope you recognize that that's the converse of step number 2. But now it lets us move on to step 9, which is pretty straightforward. AC is congruent to AC. So now we have AB congruent to AD from the givens, BC congruent to CD from step number 8, and we've just proven that AC is congruent to itself. So that allows me to prove my conclusion that triangle ABC is congruent to ADC by side, side, side. QED is an old expression that you'll see in some of the older math books. When you complete a difficult proof, it can sometimes be really satisfying to write. And it just is Latin for as was to be shown. I believe it stands for quod erat demonstrandum. Guys, that's the proof of the hypotenuse leg theorem. So you'll notice that all we knew at the beginning was that we had a leg of right triangle ABC congruent to a leg of right triangle ADC. And in this proof, we had the hypotenuse AC congruent because it was shared by both the right triangles. But from now on, we can use this theorem, and I think it's going to help you anytime you come across a triangle with a right angle. But please be careful that there will be times when side, or angle, side, or side, side is still the right thing to work. This works when you have a right triangle, a hypotenuse, and a leg. Okay, take a few minutes or less than that and check out the videos I made during Spirit Week. Thanks to Patrick and Kristen and Colin for being good sports about and being included in the video. Looks like you had a lot of fun. All right, good luck, Ramblers.
Yo, shot! Jump!